Let us consider example 2, where we want to construct a system of equations to solve for mesh currents I1, I2, and I3. Given the circuit below, we can follow our four-step procedure, such that we need to construct n KVL loops. We have loop 1, the I1 flows through, we have loop 2, the I2 flows through, and we have loop 3, the I3 flows through. Step 2 is to assign our voltage potential as consistent with our passive sign convention and to not dually label our shared elements. Starting with loop 1, we can proceed in a clockwise direction such that when we encounter R1, we apply our voltage potential consistent with PSC, and then down through R4 where we apply our voltage potential consistent with PSC. Now moving to loop 2, we start in the bottom left-hand corner and move in a clockwise fashion. R4 already has a polarity associated with it, such that we then proceed to provide a polarity across R2 and then R5. Last but not least, for loop 3, we see R5 already has a polarity associated with it, such that all we have to do is assign a polarity associated to R3. Step 3 is to construct n KVL equations. That is, we will have 3 KVL equations starting with mesh current 1 in our bottom left-hand corner. We enter the negative terminal of our voltage source, so we'd have minus Vs plus V1 plus V4. Or V1 plus V4 is equal to Vs. Looking at loop 2, we'd enter the negative terminal of our resistor. We'd have minus V4 plus V2 plus V5, and this should be equal to 0. Last but not least, looking at loop 3, we'd have minus V5 plus V3 plus Vg is equal to 0. Or we could say V3 minus V5 is equal to minus Vg. Now that we have our 3 KVL equations, we are going to apply Ohm's law to express our voltages in terms of our mesh currents and our resistances. That is, if we look at mesh current 1, we had V1 plus V4 is equal to Vs, where V1 can be expressed as I1 times R1. And then V4, we have to take into consideration that if we have a current I running through it, it's going to be the difference of I1 less I2. That is, V1 plus V4 is equal to Vs can be expressed as I1 times R1 plus I1 minus I2 times R4 is equal to Vs, where I1 minus I2 times R4 is equal to V4. Now when we look at mesh current 2, we have minus V4 plus V2 plus V5, where we already have V4 expressed in terms of mesh currents 1 and 2 and resistor R4, such that we'd have minus I1 minus I2 times R4 plus V2, which is I2 times R2, plus V5. Now V5 has mesh currents 2 and 3 running through it, where I, the current running through R5, would be mesh current 2 less mesh current 3. Such that we'd have minus V4 plus V2 plus V5 is equal to 0, expressed as minus I1 minus I2 times R4 plus I2 times R2 plus I2 minus I3 times R5 is equal to 0. Lastly, for our third mesh current, we have minus V5 plus V3 is equal to minus Vg. We already have V5 expressed from mesh current 2, which is I2 minus I3 times R5, such that we'd have minus I2 minus I3 times R5 plus V3, which is I3R3, is equal to minus Vg. Thus we have 3 equations and 3 unknowns.